So looking at rearranging equations. First things first, I want to start with the absolute basics. And if you're okay with this, feel free to just skip past it. So the first thing we're talking about is if I had something like x plus y and that equals z. We're talking about transposing or an inverse. Generally inverse operations is the most common thing we have to do here. And it just refers to the fact that if I shift a symbol from one side of an equals line to another, I take the inverse of it. So if I wanted to move y across here, the thing in front is the plus, so it becomes minus y. Likewise, if I had something like real basic 2x equals 4, I want to know what the x is. I need to get rid of the 2. 2 is connected to the x as a multiply, so when it comes across, the inverse of times is divide, and it becomes divided by 2. So that's the real basic stuff. When I expand on that in the context of equations that we actually see fairly commonly in physics, the first one I want to look at is this one. So it's v squared equals v naught squared plus 2as. And now there's a few ways that they can phrase this. You could say get it in terms of something. So rearrange this equation to find it in terms of acceleration. Or you could say that acceleration is the, if we're talking about this one, the acceleration is the thing we're trying to find. There's a lot of ways that they phrase that. They might say, make A, or acceleration, the subject. So I want to get this by itself. In order to do that, I need to move everything else over to the other side. So the first thing I'll do is I'll get rid of this, because this is the easiest. V naught squared is a plus V naught squared. So I'm going to have V squared minus V naught squared. What I'm left with is my 2as. And now I'm going to get rid of 2 and I'm going to get rid of s at the same time. If you want to break it into individual steps, that's fine. But I can do it in one step. These are both times by a. So in order to drag them over, I simply divide, and I divide by 2s. So that gives me that on this side, v squared minus v naught squared over 2s is equal to the acceleration. Now I have acceleration as a subject, or in terms of acceleration, however you want to phrase it. Next example. If I was to look at an equation like this, it tells me that 1 over the resistance total, so this is talking about electric circuits, is equal to 1 over the resistance of the first resistor plus 1 over the resistance of the second resistor. This is a very, very common mistake. A lot of people think, oh, well, everything is divided by like 1 over, so I could just flip both sides and that would be fair. But the problem is that it's actually in brackets. So if I flip it, it's currently this. If I flip it, it then needs to become all of this over 1, and that is not the same thing. So let's go back. If I had 1 over R1 plus 1 over R2, and I want to know what is R2. So I need to rearrange everything in terms of R2. Firstly, I can move this to the other side. Ignore the fact that it's a fraction, it's actually just a positive fraction. So to move it, I flip the sign, I get 1 over the R total minus 1 over R1 equals 1 over R2. And so far I'm pretty close. If I had these values, it's a lot simpler and you'll make less mistakes to just plug them in now, do this in your calculator, and then flip the answer when it's one fraction. But if you want to do it in the general form, if I want to invert both sides, remember this is plus, sorry, this is in brackets. So therefore, to flip, if I want R2, it's going to equal this flipped. So it was 1 over this, it's now 1 over R total minus 1 over R1 all over 1. And this is not the same as just flipping it, because I flipped the whole thing. I can leave it like this for now, or I can expand. But like I said, it's a lot easier to go back to this point, substitute the values, and then flip it. The next one, if I had what we call the Lorentz factor. So this is a year 12 concept, but in terms of just doing an equation, it's fine. So we use the symbol gamma, and it's 1 divided by the square root of 1 minus v squared over c squared. And now in this case, what if I wanted to find what v was? Not v squared, v. Well, there's a few things I could do. I could do something to both sides rather than invert, and you could go about it a few ways. First thing that I want to do is I want to move this to this side. So I'm going to take this whole thing and I'm going to move it up here. It was divided, so it now becomes times, and then this will become times, so if I move it, it also divides. So if that's confusing, do this first and just have all of this times gamma, and then you see that I can just divide by gamma. If you can see that in one hit, it'll save you the time. So I'll write it out. It's 1, and it's all square root, minus v squared over c squared. That's going to equal 1 over gamma. And you could see that the other way I could have done this is just invert both sides. If I flipped this, I'd have this whole thing over 1. And if I flip this, I'd have 1 over this, which is exactly what I've got. So there are multiple ways you can do this. Remember, the subject that I want it in terms of v. So I've still got more to go. First thing I'll do, if I want to get rid of a square root, I square it. I do the inverse, the opposite. So I square both sides. Important to keep brackets because this makes a difference. Doesn't matter that it's 1, but it may not always be. Square root vanishes. I get 1 minus v squared over c squared. On the right hand side, that's going to equal 1 squared is just 1 over gamma squared. Now I can move the 1 across. Remember, this is a plus 1, so it becomes minus 1. And then if you want to do it in the same line, I could move the c by multiplying as well. But I'm just going to do one step at a time just to make it clear. So I'm left with minus v squared over c squared. That's going to equal 1 over gamma squared minus 1. Now I'm going to times by c squared. This all needs to become brackets so that I don't just times one part of it by c squared. The whole thing becomes multiplied by c squared. And now I've just got negative v squared on this side. So I could do two things in one hit. I can times both sides by minus 1 to cancel the sign and change this sign, and I can square root it. So if I write this as v, it's going to equal negative of everything. So I'll put second brackets, 1 over gamma squared minus 1 times c squared. So the second brackets are probably a bit of overkill, but I'm just trying to really show the steps. And I'm also going to take the square root of this entire thing. So if I change this to minus, slap the square root in. So if we tidy this all up, I'll come over here, I can clean it up a little bit. Firstly, I've taken the square root, I've got a negative. Let's expand the negative out first. So I'll have this bit, which will give us minus 1 over gamma squared. Minus 1 will become plus 1. The c squared is still outside, so I'll leave it outside for now. I can expand out the c squared if I wanted to. Why not? So we'll go minus c squared over gamma squared plus c squared. That's all I've done. Now I've got my square root, and that's equal to v. Arguably, when we talk about mathematics, if I take a square root of something, or I undo the square, it could be plus or minus because I squared it. So if I had a negative, it becomes inverse. So you normally would say plus or minus. In this case, doesn't really matter. And we could probably go a little bit further. We could try and use some surd rules and simplify it, but I'm happy with that. I've got velocity is equal to minus c squared over gamma squared plus c squared. So that's cool. Or you could have left it as it was here. Minus 1 over gamma squared plus 1 all times c squared. and we've got it in terms of v. So that's an example of rearranging, transposing, etc. with equations.